everyone. Today we're going to proceed with another example of undetermined coefficient to solve the non-homogeneous second order differential equation. So in this example, you are given the differential equations of d2y over dx squared minus 2 dy dx plus 5y is equivalent to x plus exponent x cosine 2x. So if you look at the function fx here, is a combination of three cases. In this case, we have the polynomial, the exponent, and of course the trigonometry function. The first step, as usual, you need to find the complementary solution. There is a reason why we need to find the complementary solution first, as later you will see in the video. Find the complementary solution, we need to set the equation so that it will be equivalent to 0. We're going to replace the d2y over dx squared with m squared, and similarly this one is going to be 2m plus 5 is equivalent to 0, and we're going to find the roots for this. We see that the roots are comprised of the complex conjugate. Therefore, the complementary solution is yc, so exponent x plus 2x plus the complementary solution. So for the particular solution, we need to refer to the function fx. The basic form for this comprises of the polynomial, which is from x, and we also have a combination of exponent and trigonometry. The constant of c x, because this is actually x, that will be from the polynomial. Exponent, so it will be in this form, and a constant f sine 2x. Now if we compare with the complementary solution, the complementary solution is also in the form of ex cosine 2x, so they are actually the same pattern. Because of that, we need to multiply with x for this part, and then for the cx is sufficient. Plus x. So now we're going to see whether the proposed yp here is equivalent to the yc1. If we refer to this, because we have this additional x, so they are not the same pattern anymore. This is why it is very important for us to find the complementary solution before we obtain the particular solution. Next, we need to find the derivative of yp. So in this case, we have a cx, so we only have c. So this one will give us 0. In this case, let's say we differentiate the ex component first. We have the same expression, and then this is the part whereby we differentiate x, which is going to give us 1. So that's why we only have exponent x e cosine plus f sine 2x. And the final one is we maintain this, but we differentiate the one in the bracket. Differentiate cosine, it will give us sine, but don't forget it will be minus. And then similarly on this sine, it will give us cosine. And at the same time, we need to differentiate the omega here first to just put 2 at the front. And we can rearrange so that when we try to differentiate this function here, it will not be too complicated. X plus 1, and the bottom part here will maintain. that will be our yp prime. Or we can factorize this, so it will become this expression. So it will be easier for us when we want to take the second derivative of yp. So c will give us 0. And then let's say we differentiate the exponent x first, so this part will be the same. Okay, and then secondly we differentiate the x plus 1, so that will give us 1, and the rest are maintained. We are going to differentiate the cosine and sine expression inside this bracket. Then and don't forget, because we need to differentiate the omega as well, the omega here as well, so it will give us 2. Next one, we're going to do the differentiation for this second part. First we do the exponent first, so it's going to be similar, exactly the same. For the x will be equivalent to 1, so the rest are maintained. So next we're going to differentiate the exponent sine 2x plus this. Okay? And don't forget, you need to multiply with differentiation of 2x as well, which is going to give us 2, and then multiply with 2, so it will become 4. When we differentiate sine 2x, it will give us cos. Okay, so don't forget the minus is still there. And for the f cosine 2x, so we can simplify this expression. So this will give us minus 3 plus 2. So the y double prime is given by this expression. Next, we're going to substitute the yp, which is this yp prime, this one, and the yp double prime, which is this, into the differential equation. We have minus 2 yp, okay, and then we have plus 5 of y. And we can simplify this. Better if we simplify them in the form of sine and cosine, and of course a constant. We have minus 2c, and then we have plus 5cx and 5d. The coefficient for exponent cosine 2x. What about sine? Okay, so this one we have 3x, so 5 minus 5 will cancel off. Then we have e, we cancel off also. xf will cancel off. So we have 4f. Okay, what about this? And this one is equivalent to this. So next step, we need to compare the coefficient. Okay, when we compare the coefficient for this Ex assigned to X is equivalent to T is equivalent to 0, apply that E is equivalent to 0. So we're going to find the coefficient for the exponent cosine to X. We have 4F is equivalent to minus 1, which implies that F is equivalent to minus 1 over 4. Next, for the X. So for the X coefficient, you will see that 5C is equivalent to 1. So this, in this case, it will give us C equals to 1 over 5. For the constant, we have the x0 minus 2C plus 5t is equivalent to 0. E is equivalent to 2 over 5c, which we substitute c with 1 over 5, 2 over 25. Therefore, the particular solution is, so we're going to replace c with 1 over 5. Okay, and then we have d is equivalent to 2 over 25, and we have e is equivalent to 0, so this one we remove. So f is minus 1 over 4. Okay, so that will be the particular solution. Hence, we can obtain the general solution of differential equation yc plus yp plus with okay, so that will be the solution for this differential equation. So always remember, when you see a pattern, in this case you could see that there is a sign to x and multiply with the exponent x. They are the same pattern as the particular solution. So that's why we need to have the additional x. It's similar to a critically damped solution, if you still remember from your electrical circuit subject. Okay, so this is the end of example 3 for the undetermined coefficient. The next video or the next lesson will be on the method 2, which is on the variation of parameters. Thank you.